So one of the first things to realize about extinction is that it is a natural phenomenon. Paleogeologists and people that study all those kinds of things, have given the number of 99%. I think they just shot that out there because they realize the vast majority of things that have lived on Earth no longer live on Earth. The cart is in back through there, and then on your left. So the fossil record for the most part is actually also very incomplete. The majority of life on Earth does not form skeletons and hard shell substances that form fossils, so we're leaving a big part out. But I think it's sufficient to say that, number one, most of the things that live on Earth no longer live on Earth. We've got 5 mass extinctions. And second of all is that it is a natural thing for species to go extinct. So when we're looking at this particular question of how we can reduce the species or reduce the number of species that do go extinct, we have to separate out what we call the background, which is pretty much the same as your natural, so you get the point for that. So this is the rate at which species would normally go extinct. You should not have your phones out. Put them away. Okay. So obviously, to be to make a difference, it's the same thing with radiation. There's a certain amount of background radiation that always exists in the environment around us. When it's becoming dangerous is when we look at when it goes above that level. So you got to subtract out that background rate, or be able to specifically point to species that you see that we know are having an impact to the point where they're likely to go extinct. And there's you can't just say, oh well, they were going to happen that way anyway. So that's what endangered species actually is one that is in danger of going prematurely extinct. So that's the, like I said before, the extinction of the prematurely extinct is the fact that it wasn't supposed to go already anyway. It's not an easy thing to determine either. You can't really look at a population and say, well, it's about your time, so nice knowing you. See you in the next universe. But it happens. That does happen. I believe some estimates have the average lifespan of a species is 5 million years. This is just based on the fossil record. There are some organisms, though, like the horseshoe crab, that are hundreds of millions of years old, and basically the same form or species of it. So there's a lot of variation there. Different types of extinction. The extinction that we most think of as extinction, most people associate with extinction, is when there are no longer any members of that species. Erase is fine. I'm just going to go with a simple gone. That we know of, that we can observe on Earth. So this is also an area where you never really know for sure. The coelacanth, for example. Does anybody know what the coelacanth is? Coelacanth? It's a fish. Coast of Africa. You have marine science? I know it's about marine science. Anyway, the coelacanth, very interesting fish. I'll show you guys a little video on it later. Is what's called a lobe-finned fish. So not only as a species, their whole class of fish was believed to have gone extinct with the dinosaurs. We see it before the dinosaurs. There's the mass extinction period that happened there. A lot. It wasn't just dinosaurs. A lot of stuff in the ocean also died out, and everybody figured it was extinct. And then in the 1920s, fishermen off the coast of South Africa pulled some in and saw this fish that they had never seen before, and it was a very odd-looking fish. What's odd about it is the fins actually, before rather than being fins that just stick out from the side like most bony fish have, the radial type fins, they've got a little protuberance that actually has bones in it that are similar to leg bones that you find in animals and stuff. So it's called a lobe-finned fish, and there was only example of it that is still surviving. There's a lot of them in the fossil record before, like I said before, the dinosaur mass extinction. Anyway, so sometimes we don't know. Sometimes things may come back. There's other examples too. Those are called Lazarus species, by the way. So that's what most people think of extinction, but you also have extinctions within an ecosystem that we call local extinctions. The organisms may have died out in that population in that area, or they may have moved out because it's within a particular ecosystem. Genetic extinction is more like a condition of a population. And what it is when there's just so few members of that population left that there's significant inbreeding, and inbreeding does not filter out the bad genes. It tends to magnify the bad genes within a population, so you see a number of defects and things like that. So when they look at these species, these populations, and notice these particular characteristics and look at numbers and things like that, sometimes they will just kind of define or say that that particular species is genetically extinct. For example, the Florida panther. The Florida panther was deemed to be genetically extinct in the late 1980s when its population was in somewhere in the order of the 30s. They were seeing a lot of things like birth defects. Their testicles were not descending in the males, which made them sterile. So there's a number of different things there. And with a population of 30, the problem is, of course, that you can't breed these out. They have to breed within themselves, and therefore these problems become magnified. So you get to the point when the population is so small and these things start to show up that they are believed to be genetically extinct. So fortunately I'd say for us and for big cats in general in Florida, it's a subspecies. Florida panther is a subspecies of the American cougar, which is pretty much what you see with pumas in South America and the mountain lions, etc. you see in the West. And in Texas, they have one that's very similar to the Florida one. Of course, it's similar environments there. And so they brought in Texas cougars to interbreed, or outbreed is actually what they call it, with the Florida panther. And now the numbers are approaching, I think, 200. But the numbers have come up considerably. However, you no longer have specifically the Florida panther subspecies. I'm pretty sure all the original population that was completely Florida panther has probably died out by now from old age or whatever, or some other reason. However, we now have a large big cat population. Some people are kind of against it. They're like, well, we won't have the Florida panther anymore. That's true. We've got Florida, Texas hybrid panthers, but we've got big cats in Florida again, so I think that was a good thing. Otherwise, it would have died out. So that's what they call genetic extinction. Then you have commercial extinction, also kind of a property of a population. This is going to be for things, primarily fish, of species that we still harvest for profit from the wild, and that's the main thing that we still take out of the wild as a product, and as an animal, you know. The numbers can get to the point, low enough to the point where it's so hard to find them and catch them, etc. It's not profitable to do so. And in the past, you know, just the techniques and everything we had did not allow us to bring most types of marine fisheries to that point, the ocean being so vast and the populations being so large. But as we learned back when we talked about fishery management, that has changed, and certain populations have gotten down, though not really at much danger of a biological or even genetic extinction. They are down to the level that they really can't be harvested in large amounts anymore, and the populations need to recover. So that's part of the whole sustainability things. And if you do things the right way, the populations, you know, you take the older ones and the younger ones will repopulate. So that's called commercial extinction. Any questions about extinction? You know, the natural state of it, different types of extinction. Okay. So there are certain species that are particularly vulnerable to the environmental things, the anthropogenic things that people do to damage them, or just environmental changes in general. Those, of course, have low reproductive rates. That's what you would expect, you know, because they don't have the ability to recover quickly, numbers-wise. Limited geographical ranges. That means that they are fairly isolated to a particular part of the world. Then obviously if you do damage to that population there, you've got no way to recover it, no way to bring other animals in, etc. If they have very specific niches and requirements, whether it's food or shelter, etc. One of the, a good example of this one is the panda, because the Chinese giant panda depends upon bamboo shoots. Now bamboo is a pretty prevalent plant worldwide, but specifically in the bamboo forests of China has been harvested tremendously because the Chinese use bamboo for practically everything structural, and therefore that's why this particular species is endangered, why it's suffered from that. People aren't out hunting pandas, for example, and things like that. But it's habitat destruction, as we'll see that's a big thing for a lot of them. But the thing that made that habitat particularly precious for that panda was the fact that of its diet that mainly ate those bamboo shoots and things like that. You also see that with big predators and things that need to go long ranges to catch their food. So that's, of course, they're at the top of the food chain. And we know that at the top of the food chain, there's going to be, what, more or less of them than the other things up at the top of the ecological pyramid. For the students, do you have a lot of predators and a little bit of prey, or the other way around?
What?
Less at the top, less predators. That's why they'll have these low reproductive rates. So if you need a good price on reproduction, we have low reproductive rates. The predators, of course, like tigers, for example, breed every 2 to 3 years. So that's difficult when you have an impact on that population. Plus, what was that other phenomenon that happened because of toxins in the environment, the top level predators? Where it was worse for them. Remember? Anybody? Biomagnification. Thank you. Very good. So they're also suffering from that. So then another thing with the big predators, they have to range over long distances to get their food. So that can be a problem. And if they have limited genetic diversity for one reason or another, most of the times it's when the population numbers drop that they become less genetically diverse. But sometimes you have genetic drift, you have cutoff of gene flow and things like that just tends to concentrate populations and make them less genetically diverse, more susceptible to diseases and things like that. One of the things we see, and you notice that there were 2 questions on there, I got rid of one of them, but the National Board likes to focus on this, I think probably because it's you can study them so easily because they're isolated, is island populations. They also have been, if we look around the world, some of the worst environmental scenarios have occurred on island populations. And it's kind of obvious, I think, should be. First of all, of course, an island has less resources. Less land means less plants. The plants are the base of the food chain. Therefore, they have less resources in that particular area. Fresh water is oftentimes a limiting resource. To have an actual aquifer on an island, you have to have a certain area and mass of land. If you don't have that, then the species are always going to be relying upon the rainwater. So that can be hard to adapt to. They're more susceptible to tsunamis and earthquakes and hurricanes and other kind of things there because they're small and they're there and things like that. And they don't get a lot of input from the mainland. They don't have the ability to have immigration help them with population problems. So what you saw in that one question on there, it showed islands with several properties. Recall that if you can in your when you think about this. And it said which one was going to be the most biodiverse, which one's going to have the most diversity of species, be the healthiest, basically, the most stable ecosystem. So your 2 factors, you want to minimize that. So first of all, the bigger island was better. It had more resources and stuff, so it would tend to be more biodiverse. And the closer it was to the mainland, where it can get, through migration and things, species coming in and landing on it, living on it, then you can see that as making it more stable. So if you're thinking about that particular question, you do your pretest again. That's what you're looking for. Closest to land, bless you, and as big an island as possible. All right. Finally, there are 2 different ways really to approach this problem of premature extinction. One of them is a species-based approach. Now, this is what has happened in the past, and I'll use the panda again because it's such a great example. And there's something called species vanity, which is simply the fact, psychologically speaking, that people like to support things that are cute. And pandas are definitely cute. Most of your look at the poster over there on the wall with the panda and the tiger. Aren't they all cute and fuzzy? And granted, some of them would definitely eat your face off or whatever. But these look like things. Oh, how could we let that go extinct? But the fact of the matter is there are thousands of endangered species that are plants. Or that are funguses or other things that are not glamorous that you don't want to cuddle with. You wouldn't want to put a poster of it on your wall necessarily. And therefore, we will oftentimes tend to neglect those. So with the species-based approach, the good part of it is that it does peak involvement. As far as environmental issues, protecting endangered species is one of the ones that gets the most attention from people because, like I said, let's save the cute rhinos and the whales and things like that. It gets more attention oftentimes. So that's the good side of it. The bad side of it is if you neglect the actual problem, which is the habitat. And that's the biggest problem we see with endangered species. If you have For example, the panda, you do everything you can to protect it. You make laws against it. You put armed guards around it, although people aren't really hunting pandas. But you do what you can to protect it, but you don't protect its environment. Even if it recovers as a species, it doesn't have that habitat in there to recover into. It's kind of pointless. So there's been a shift in ecological thinking and priorities in the past couple of decades away from targeting specific species to try to help, to looking at areas where species tend to be going in general towards extinction and preserving that habitat and trying to reduce the things that are making that happen in those areas. So one of the main things that means is preserving land, and that's what the heck? Perfect? Yes, it's not perfect. So that was actually a good answer.
Heck yeah.
Practical. Well, it wasn't what I call a correct answer, but it was creative enough that, nothing's perfect. So I got to put that. Not practical, okay? That means you basically have to say to all these people, you can't use the bamboo in this forest anymore. Even though all of them would probably say, oh, I love the pandas. It's a national, it's a thing of national pride. They're beautiful, cute, etc. But I need to build my house, or I need this or that or whatever else, or I work at the bamboo processing factory, and I'm going to lose my job if we can't harvest this bamboo. And so that's when it becomes impractical a lot of times for people. So, any questions? What makes the species more vulnerable? What the habitat versus the species approach means?